Show that e to the x is equal to the sum of its Maclaurin series. F of x equals e to the x equal to the sum at n go from 0 to infinity of x to the n over n factorial if the remainder is 0 as n go to infinity. We let d be the positive number so that the absolute value of x is less than or equal to d. Then the n plus 1 derivative is e to the x, which is less than or equal to e to the d power. The Taylor's inequality with a equal to 0 and m equals e to the d states that if the absolute value of x is less than or equal to d, then the remainder is less than or equal to m, which is e to the d, over n plus 1 factorial times the absolute value of x to the n plus 1. This is e to the d times x to the n plus 1 over n plus 1 factorial, and they tend to 0 as n go to infinity. This is because we saw that with these limits at n go to infinity, the factorial is much bigger than the power. And so by the squeeze theorem, this remainder is squeezed between 0 and 0. Therefore, its limit is 0 at n go to infinity. And that is what we want to show. The remainder go to 0 so that e to the x equals to the sum of the Maclaurin series. And so e to the x can be represented as the Maclaurin series x to the n over n factorial, which is 1 plus x over 1 factorial plus x squared over 2 factorial plus dot dot dot. For all x, this is true for all real numbers. And so it is true for x equals 1. We plug in x equals 1 into this series to get 1 to the n over n factorial, which is the series 1 over n factorial. And so e is a number such that e is 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial plus dot 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 plus 1 over n factorial. The function e to the x can be expressed at the series x to the n over n factorial. So e to the x squared is the series x squared to the n over n factorial. One of these applications is that to find the antiderivative of e to the x squared, we can just simply integrate the series term by term. And so the antiderivative, or the integral, of e to the x squared dx is the integral of the series x to the 2n over n factorial. Using the power rule, the antiderivative of x to the 2n is x to the 2n plus 1 over 2n plus 1. N factorial is still in the denominator. We can integrate term by term to get the same series.